Okay, so today we're going on to our 3-4 3D notes. We're going into some trigonometry. It's still triangles. We're just going to be dealing with trigonometric functions. I think these notes, they printed wrong, so there's some things that we're going to have to fill in and write in. I don't think that yours have that information. So we're going to start with the three trigonometric functions and what they are. So we have sine, cosine, and tangent. And we shorten these with sine being S-I-N, and we have cosine and tangent, and that's how you're going to see them on your calculator when you have to do calculations with those. So we use the acronym SOHCAHTOA to help you remember formulas for each of these functions. So for the first one, it's SO, S-O-H, and the S stands for sine. So the sine of, and we're going to use this symbol here, and that is called theta. So I'm going to make a little note to the side here. This is called theta, and that just stands for an angle. So the sine of theta equals, and the O and the H means opposite over hypotenuse. And we'll get to what each of those mean in just a second. So next we have CA, and that means cosine of theta equals adjacent over hypotenuse. And then we have tangent of theta equals opposite over adjacent. So I'm going to use this triangle over here to the right to show you what each of those words mean. So this is the part that didn't copy over. We're going to call this angle right here theta. And from that angle, we're going to label the sides opposite, hypotenuse, and adjacent. So we know the hypotenuse is always across from the 90-degree angle, right? So this side is the hypotenuse. And that will always be the same for every triangle. Across the 90-degree angle is the hypotenuse. And the next we have from the theta, which one is opposite of this angle? And that's the one that you can draw a line across to. So that would be opposite. Now these are the ones that are going to change based on where theta is. And you'll see that in our next examples. And then we have adjacent. Adjacent is the one that is touching the angle and right next to it. But it can't be the other one that's touching it because that's the hypotenuse. So this one is adjacent. And we'll see how that changes in these next three here. So we're going to label each side opposite, adjacent, or hypotenuse. And the theta symbol didn't copy over, so we will put that in there as we go along. So there's our angle, theta. So let's start with labeling the hypotenuse. We always know that one is across the 90-degree angle. The opposite one, opposite of the angle. And the adjacent one is the one that is touching it, or right next to. Adjacent means next to. Okay, and the next one, our theta is right here. So we have the hypotenuse. I'm going to shorten them now to make it faster. The opposite and the adjacent. The next one, our theta is right here. I want you to pause the video and try to label this one on your own. Check your answer with mine, see if that matches up. Okay, now we're going to use our SOHCAHTOA formulas for triangles that now have measurements. So before we were just labeling, and now we're going into using numbers with these. So for our first example, our theta is going to be up here in this corner. Again, these just didn't copy over. You won't have to like pick a random one. Just didn't copy over there. So this is our theta, and I'm going to go ahead and label these. I would recommend labeling them every time or you will get confused. I even get confused sometimes. And writing out SOHCAHTOA every time is also really helpful. Write it out for every single problem if you have to. It'll really help you remember it. So the sine of theta equals opposite over hypotenuse. So the opposite one is 8, which is right here, and then the hypotenuse is 17. So 8 over 17. If you do that in your calculator, it's about 0.47, but you can just leave it as a fraction. So let's go on to the cosine of theta. Cosine is adjacent over hypotenuse. So we have 15 over 17. And then finally we have the tangent of theta, which is the opposite over the adjacent, so 8 over 15. And we can just leave those in fraction forms for now. We'll have to estimate later on when we are actually finding the side lengths. That's what we're going to do in example 3. Okay, so first we need to label our theta, which is this one right here. Oh, I'm sorry. Wrong one. So for these ones, I'm actually going to give you an angle measurement so we can actually find the side length. So this angle here would be our theta, but we actually have a measurement for it this time, and that is 53 degrees. So I'm going to go ahead and write out SOHCAHTOA again. And then I'm going to label my triangle based on that angle measurement. So if this is 53 degrees, this is always the hypotenuse, this one is opposite, and this side is adjacent. Now, we want to solve for x. So we have to think to ourselves, which one are we going to use? Sine, cosine, or tangent? And looking up at these, which one has the sides that we have? We have opposite, right? We need to solve for x, and we're given the hypotenuse. So which one has opposite and hypotenuse? Sine. So we're going to use sine to solve this. Now, in place of that theta, we now have an angle measurement. So we're going to say the sine of 53 degrees, you put that in parentheses there, equals, and we know that's opposite over hypotenuse, right? So that's x over 23. I'm just going to erase this part here. So now we have an equation. Sine of 53 equals x over 23. And now we want to solve for x. So if we just solve this like a normal, regular equation, we would start by multiplying both sides by 23. So that those cancel out. And then we get 23 times the sine of 53 degrees equals x. Now this you just want to do in your calculator. Make sure you use all those parentheses or you won't get the correct answer. I would recommend typing in the sine of 53 first, seeing what that is, and then clicking times 23. So in your calculator, type sine parentheses 53 times 23 equals. And we should get 18.4 if we round. And that is our answer. Okay, let's go on to the next one, B. we are given that this angle is 42 degrees. So I'm going to label these. And we are given hypotenuse and adjacent. So which one should we use? This time we're going to use cosine. So the cosine of 42 degrees equals a over h, adjacent over hypotenuse, so x over 9. Again, we would do the same thing. So 9 times the cosine of 42 and just use your calculator to figure that out. And we would get that x equals 6.7. Okay, we have 4 more problems to try and then 2 word problems. So I'm going to work out C and D with you, and then I want you to try E and F on your own. And then I will just give you the answers, and then you see if your answers match up with mine. So again, I'm going to write out SOHCAHTOA at the top. Always helpful to do that. And then this is 35 degrees. I'm going to go ahead and fill these in. 61 degrees, 45, and 28. Okay, so for the first one, we have adjacent and opposite, right? That's what's given to us that we need to find out. So we're going to use the tangent of 35 degrees equals x over 41. We solve that, and we get that x equals 28.7. The next one is going to look a little bit different. So I'm going to go through this one with you. We have hypotenuse and adjacent. So we have the cosine of 61 degrees equals 24 over x. This time our x is in the bottom, so we can't do the cosine of 61 times 24. If you wanted to work this out like a regular equation, we would multiply both sides by x. So you'd get x times the cosine of 61 equals 24. And now to solve for x, you'd have to divide both sides by the cosine of 61. And when you put that in your calculator, you should get that x equals 49.5. Okay, so you try E and F on your own, and I will just write the answers out for you. All right, check your answers on those, and we're going to go on to the 2 word problems that we have. So again, like before, drawing out these word problems will really help you. First thing I want to go over is that these talk about angle of elevation and angle of depression. Those are easy to get confused sometimes, so I'm going to draw a picture to help you. So when we have angles, if an angle goes up like this, that is an angle of elevation. And then when an angle goes down like this, that is an angle of depression. So this says that at a point on the ground 50 feet from the foot of a tree, the angle of elevation at the top of the tree is 48 degrees. Find the height. Okay, so I'm just gonna draw a tree. And then at a point on the ground 50 feet from the foot of the tree. So here we have the foot of the tree, 50 feet away. An angle of elevation. So we're going up. So we're at our ground point, we're going up. If it was an angle of depression, it would go down like that. And we want to know the height of the tree. and our angle of elevation is 48 degrees. And now we just use our SOHCAHTOA to solve. So we are given adjacent and opposite. So we're going to use the tangent of 48 degrees equals x over 50. So the tangent of 48 times 50 gives us that x equals 55.5 feet. Okay, we have one more. You can pause this one and try it on your own if you would like. I'm going to work through it with you as well. So from the top of a lighthouse, 160 feet high. So I'm just going to draw a box here for my lighthouse, and I know that it is 160 feet high. The angle of depression of a boat out at sea is 24. So I'm going to go down with my angle of depression. And we want to find the nearest foot of the distance. So we're looking for the distance. And our angle of depression is 24. So this is our angle of depression, because this would be an angle of elevation, because it goes up. So we have opposite and adjacent. So we're going to use tangent again. The tangent of 24 equals x over 160. So then if you do the tangent of 24 in your calculator and take that times 160, then you'll get that x equals 71 feet, or 71.2 feet. And that is all of our notes for 3-4.